Today's lesson is 4.5, which is using similar figures. So what you're going to be doing in this lesson is you're going to be taking figures that are similar and using their ratios to find an unknown side or angle. And I think for this section, we're just going to be finding unknown sides. So an indirect measurement is a method of using proportions to find an unknown length or distance in similar figures. So let's look at example 1. So in example 1, we have two triangles. We have triangle ABC, and it is similar to triangle JKL. So if we look at our triangles in our book, you will see that line KL is an unknown. So how do we find the length of KL? Well, what we're going to do is use our ratios, solve using the cross products or cross multiplying, and then divide to get our unknown by itself. So step 1 is to find your ratios. So they say that line AB is to line JK as line BC is to line KL. So if you look down in our triangles, you'll see that the triangles are similar, but they're not necessarily pointing in the same direction. So angle C and angle L are similar, K and B are similar, and A and J are similar. So let's put some numbers into our lines. So AB, if we look at our triangle, it is 8, and JK is 28. On the other side, we see that BC is 12, and KL is our unknown. So to solve this, we're going to cross multiply. So that's going to give us 8x, and then 28 times 12. So 2 times 8, 16, 2 times 2 is 4, 5, 10 spot, 28, add that together, we get 6, 5 and 8 is 13, so 336. So now to solve for x, we have to isolate x, which means we divide this side by 8, and then we divide this side by 8. So 336 divided by 8, 8 goes into 33 4 times. It's 32, 16, twice. So x equals 42. Okay, so that's fairly simple. A lot of work that you have to show, but in the end, fairly simple math. X equals 42. We're using our ratios to solve for an unknown. So the biggest part is making sure you're setting up your ratios properly, because if you don't set your ratios up properly, you're not going to find the correct unknown. The second part of that wants you to find angle Y. Well, we know, or the measurement Y, which is the measurement for angle K. So we know that angle K corresponds with angle B, and in our book it gives us that the measurement for angle B is 103. So if they correspond, the angles in our similar triangle is going to be the same. So angle K will also be 103. Okay, let's look at example 2. We have some squares, rectangles in example 2. So example 2 says a volleyball court is a rectangle that is similar in shape to an Olympic-sized pool. What they want you to do is find the width of the pool. So they give us 2 sides. We know that these shapes are similar, so the first thing we're going to have to do is set up our ratio. So if we start with length, they start with the length of the volleyball court, so 18 meters over the length of the swimming pool, which is 50 meters. And that ratio is going to be proportionate to the other ratio of 9 meters over x. Now again, in order to solve for x, we're going to cross multiply. And that's going to give us 18x equals 50 times 9, so 450. Now we want to isolate x, so we're going to divide each side by 18, and that will cancel out. So then we're just going to take 450 divided by 15, so 450 divided by, 18, I don't know why I said 15, by 18, so 2 times 8 is 16, 2 times 1 is 3, so that gives us 36, 15 minus 6 is 9, it becomes a 3, 90, how many times does 18 go into 90? I'm not sure I did that right. Would be 4. I think I did my math wrong on this. Okay, let me see. Let's try 5. Okay, 5 times 8 is 40. Oh, that's right. Okay, so your answer is 25. So x equals 25. So the pool is 25 meters wide. So again, make sure you're setting up your ratios correctly, cross multiply, and solve for x. And our last example is that they want you to estimate the height of the totem pole. So you'll see problems like this a lot throughout your math career. So you'll have this item that's standing up on the ground, and this is the shadow of that item. This is called your hypotenuse. Okay, this is going to be a 90-degree angle. This is the shadow. So here's the totem pole. Here's the shadow. Okay, and we have the length for the shadow is 15.5 feet, but we don't know the height of the totem pole. So what we're going to do is stand in the same space with the sun hitting you in the same angle, measure your shadow. So here's a person, and their height is 5 feet, so not a tall person. So 5 feet, and their shadow is 3.75 feet. So now we're going to use their own shadow of a person to figure out, using the ratio formula, to figure out an estimate height of the totem pole. Okay, this is only an estimate because this system is not an exact system. So let's put those numbers into ratio format and solve for our unknown. So we would have our unknown height of our totem pole, x, over the height of our person, which is 5 feet. And that's going to equal the length of the shadow of the totem pole, which is 15.5, over the length of the shadow of the person, which was 3.75. Okay, so and again, we're going to cross multiply. We're going to get 3.75x is going to equal 15.5 times 5. 5 and 5 is 25. 25 and 2 is 7. 27, sorry, 5 and 2, 7. We got 1 decimal. So 77.5. So 3.75 divided by, 77.5 divided by 3.75. Now what our book did was they rounded these numbers so that it was easier to multiply. So let's try that. They did, because we could solve this and find the exact, or we can round, and they have x over 5 equals, they round that up to 16, and they round this up to 4. So 16 oh, well, we don't need to cross multiply because 4 goes into 16. So it's going to be x over 5 equals 4. Multiply each side by 5 to cancel out your x, and you get x is about 20. Now let's do our math up here with the 77.5 divided by 3.75 and see how close we were. So we have 77.5 divided by 3.75. Bring over your decimal. So 375, let's try 2, so that's going to be 10, 14, 750, 0, 2, 100. So we're pretty close because now we're going to bring down another 0 and into there, and we have a decimal. So we can see that we're close. Our estimating it by rounding up to the whole numbers is close. So the totem pole is about 20 feet tall. Okay. So that we are not going to do any of the think and discuss questions, so you can go ahead and get started on your homework.